Hi, my name is Brandon Graisley. I'm a high school math teacher. We're going to learn how to determine a polynomial function's equation by looking at its graph or by looking at a description of some of its properties. So we're going to have two examples that we're going to work through. I'm just going to show you some strategies. So here's example one. Polynomial function f it has two zeros. I'm going to tell you about them. So the first one happens when x equals -3. And it has order 1. The second zero happens when x equals 2. And it has order 2. So that tells us quite a bit about it. One more piece of information that we need to be able to finalize an equation, though, I'm going to tell you that the y-intercept is +9. And so our challenge here is to find an equation to represent this polynomial. Maybe I'll just draw a little sketch here to go with this. You don't need to draw a sketch, but I'll help you. It'll help you to be more confident of your answer at the end. So at x equals -3, I'll just put that about there. We have a root, and at x equals +2. So that's -3, +2, let's say about there. And the y-intercept is 9. Alright, that's up here somewhere, maybe way up here, but that's good enough for my little sketch. And I know that this root is of order 1, and from there I have to get up to 9, so it's going to be going in this direction. It can't start up in quadrant 2 and move down to quadrant 3 because I won't be able to get to 9 without crossing back. So I must have a curve that looks like this. And the next root at x equals 2 is of order 2, so that means it has to kind of bounce off of there. It's going to look like a parabola in that area. And that is the final root, so it doesn't return back downwards, it's going to continue upwards. So that's essentially what the curve looks like. You know, it's just a sketch, this isn't perfect, but it's the right shape. Things are going in the right directions, and I know that there's a y-intercept there. So we start by writing a partially completed equation. So maybe I'll write down the word solution here. A partially completed factored form equation. We're going to use factored form because we know about zeros. Is this. F of x equals, and the big thing we don't know is the original parameter a, the stretch or compression factor. We don't know that, but we do know a lot about the factors themselves. We know that there's a factor x plus 3. Could write x minus -3. We always subtract the root. That root is -3. It ends up with a +3 here. And then the order of it is, it's order 1. I'm going to write the exponent, although we don't usually for 1. And the order of the second factor, that's a -2 because the root itself is a +2. The order there is 2. So now there's my cubic function, 1, 2, 3. And that's the cubic shape. I just don't know what a is. Thankfully, we do know one more piece of information that we haven't used in our equation yet. We haven't used the fact that the y-intercept is 9. So we're going to substitute that other known point. The known point, the y-intercept is 9. I'm going to write it with function notation. The y-intercept means that's when x equals 0, f at 0 is 9. So I'm going to substitute that in. I'm going to use a color to do it so you can see exactly what's happening. F at, so I'm substituting the value 0 in for x everywhere. F at 0 equals, we still don't know a, but we now, for this, we're evaluating at x equals 0. And then still x equals 0. Now we haven't put the value 9 in yet because 9 is f at 0, and I'm going to replace this side of the equation now with the number 9. That's the substitution of the value 9. You could have written 9 right away. 9 equals this stuff, but I'm trying to show you how it all works out. 0 plus 3 is 3. 0 minus 2 is negative 2, and I'm going to square that right now to get positive 4. So I have 9 equals a times 3 times 4. That's 12a. 9 is 12a. Dividing both sides by 12, I'm going to reorganize a little bit too. A equals 9 over 12, or better yet, 3/4. Now we had a partially completed equation there, and now I know the unknown parameter a, so we can finish it off. An equation for f of x is f of x equals, sorry, let me make it so you can see the original one. Instead of a, I'll now write 3/4, and then we have x plus 3 to the exponent 1, which I will leave off now, and x minus 2 to the exponent 2. And that is our finished equation for the function f. Okay, let's try a second example. This time I'm going to work with a graph. Polynomial function, and we'll call it g of x this time. Has the following graph. So bear with me for my sketch here. And we'll put the y-axis about there. And this curve looks like this. Okay, so it's going through this point 0, 0. It's also going through this point here at x equals 5. And so far that's not quite enough to finish this off. All I've told you about is that there are 2 zeros, and you know a little bit about maybe what the order of those zeros are. I have to give you an additional point in order for you to be able to finish off the complete equation. So I'm going to give you this point over here, which is the point -4, 2. Now that might seem innocuous, but it's going to make our life a little more difficult later on. So let's find an equation. Once again, we're going to start with a partially completed equation. Let's write down all of the information that we know. The function g of x has, once again, 2 zeros. The first one happens when x equals 0. Now take a look at how this comes in. This is one of the, it does cross the axis, but it crosses it in that sort of S-shaped pattern where it's curving towards the point and then it curves away again. That looks to me like an order 3, 0. It looks like a cubic on its own. It's not order 1 because it doesn't just cross smoothly, it's kind of curving on each side. Now it could be order 5 or 7 or 9. We can't really know that from a graph, so our convention is to choose the smallest one, which in this case is 3. So you're, unless you know something else about it, we're going to say that that is order 3. Now our other one here happens when x equals +5, and that one is more clear. I think it is of order 2. I suppose it could possibly be of order 4, but it would look a little more squarish than that in my opinion. And I drew it, so I'm calling it an order 2. So you're basically going to have zeros that are of orders 1, 2, or 3 as you go along, unless you know something else about the curve for a different reason. And we also, once again, have that other point, -4, 2, that we know about. So a partial equation, or partially completed equation, is, so I'm going to write down g of x equals, we don't know a, but we do know 2 roots, which give us 2 factors in the equation. Now the first root is 0, so I could write x minus 0 in brackets, but that's not necessary. Instead we can just write the letter x, the variable x. and we put the exponent 3 on it. I could have once again have written x minus 0 to the exponent 3, but that's not necessary. But for the other one I will need x, and that's a positive 5 root, so I have a negative 5 in the equation, and that's of order 2, so it's squared. Now that is 1, 2, 3, 4, 5. We have a degree 5 curve, and I'm noticing that we start way up here in the second quadrant and end in the fourth quadrant. Now a degree 5 polynomial would normally start down here and end up there with a positive leading coefficient, so this will have a negative leading coefficient. A is going to be a negative number, so I can check at the end, did I get a negative answer? If I didn't, I've made a mistake somewhere. So a little way to double check some of your work. Alright, so now we're going to make a substitution. In the last example we substituted the y-intercept. Now the y-intercept here, we do know it, it's 0, but if we were to substitute 0 into this equation, x would be 0, this entire side would be 0, including the a would all go away, and you wouldn't be able to learn anything about a. So you have to substitute a point that is not one of the roots that went into making this equation. You have to substitute a different, unused bit of information. So we can substitute the point negative 4, 2. I'm going to do that by writing this. We're going to substitute, I'm sorry, not f, g at negative 4 equals 2. The x value is negative 4, the y value is 2. So let me start filling that in. G at, grab that color again, negative 4 equals, we don't know a, instead of x I'm filling in negative 4 everywhere. On the left hand side, we do know what g at negative 4 is, it's 2. On the right hand side, it's time to start simplifying, and these are big numbers. 4 and 2 were quite small, but these are going to end up being large here. Negative 4 cubed is negative 64, and over here we have negative 9 squared is 81. Those are very large numbers, because I'm now going to multiply everything together. Now, maybe I'll do that right now. 2 equals, when I multiply those, I get negative 5,184. I did use a calculator for that before I started. And that's times a, dividing both sides, maybe I'll do that now, by negative 5184. I'm going to get this. A equals, simplifying this, negative 1 over 2592. So that is a tiny, tiny fraction, and we end up with a final equation. A final equation, or an equation I suppose, for g of x is negative 1 over 2592 times x cubed times x minus 5 squared. Okay, thanks.